Right. Good evening, all. Let's start the class. Right. So today we are going to draw the Lewis structures. So Lewis structures is one of the main part of our syllabus in the uh, second lesson. Right. So I am going to draw what I have given in the class. Right. I think I have given you some homeworks, but there are something that we need to learn from those homeworks as well, right? So therefore, we are going to learn. I'm going to discuss about those homeworks. ठीक है, मैं गुड़क देवल दिला दिया ना. I'm going to draw them, right? Now the first one is SO4 2 minus signs. So out of these two, obviously sulfur should be the central atom. So central atom is sulfur. Then valence electrons from sulfur, that is 6. Valence electrons from oxygen, that is also 6 into 2. Electrons from charge, that is plus 2. So altogether there will be 6 plus 12 plus 2. Then this is 18 20. Then electron pairs. Electron pairs is 10. Then placing the bond pairs first, right? So the sulfur will be the central atom. Then oxygen will be the leaf atoms, or the cone atoms, right, or terminal atoms. Then placing the bond pairs 1, 1, 2, 3, 4, right? Then after that, we need to place the electrons, so the lone pairs for each and every uh, atoms like this. Let's place this one. We have 10, 6, and we have 6 into 4. No, sorry, I have done a mistake here. This is 6 into 4. 6 into 4. Let me correct that one. Not 6 into 2. This is 6 into 4. 6 into 4 means there is, we have to erase this one. 24 plus 2. So all together it will be 32. Then 16. So we need to place 16. All right. So in order to place 16, we can do like this. Now we have placed 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So altogether we have placed 16 then. Then we need to take the formal charges. Oxygen, each and every oxygen atom we have placed, if you can see, 8 electrons. Sorry, 7 electrons, right? We have placed 7 electrons around oxygen atom. One of the bond pair electron is belongs to sulfur. So each and every oxygen atom is having -1 charge like this. And sulfur is having +2 uh, +2 formal charge, because sulfur is taken or we have placed only 4 electrons for sulfur, but sulfur we have to place 6 electrons, so therefore this should induce +2 charge. Then in order to eliminate this one, we need to do the bond pairs or the dative bonds. One we can donate like this and one we can donate like this, right? Now why we do two donations from two oxygen atoms? Because +2 charge of +2 formal charge is on top of sulfur atom. So at the end of the day, we can draw something like this: sulfur, oxygen, oxygen, and oxygen, oxygen. There will be a single bond in between these two, and there will be a double bond in between these two, like this. You can see, you can draw it like this: sulfur, oxygen, the double bond, the double bond in between these two, and we have only two lone pairs. Here we have three lone pairs. Here also we have three lone pairs. Here we have two lone pairs. So the charges will be here -1, here -1. So if I go for the dot dash one, here we have a single bond, minus, double bond oxygen, oxygen minus, double bond oxygen. So this is the Lewis dot dash structure for SO4 2 minus ions. We need to show the lone pairs as well, like this, right? So it's a very simple thing, but you should not do any mistakes as I did. So uh, identification of the bond pairs and the lone pairs and the formal charges, that is a critical thing. If you are not clear how I have derived the number of the electrons that has been assigned for sulfur, here 1, 2, 3, and 4, because other electrons belongs to oxygen, right? But sulfur should give 6 electrons. We have placed 4, so +2 charge should be induced. All right, so the formal charge should be +2. So that's how you derive the formal charge, right? Okay, now let's go to the next one. කාට හරි මේක ඇඳ ගන්න ඕනද? පොඩි වෙලාවක් දෙන්නම් කුටක් ගාලා හැමෝටම ඇඳ ගන්න. Right, next one. So the next one is, we have been asked to draw PO4 3 minus ions, right? So let me write like this: PO4 3 minus ions. So the central atom, obviously phosphorus, then valence electrons from phosphorus, that is 5. Valence electrons from oxygen, that is 6 into 4. Then electrons from charge, that is plus 3, right? So altogether, total electrons is 5 into 24, 5 plus 24 plus 3, that is 32. Altogether 32. Then electron pairs, 32 divided by 2, that is 60. Now we have to place them. Now when we are going to place them, phosphorus is the central atom, oxygen, 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 and oxygen. Then the bond pairs, let me take something like this. So the bond pairs will be 1, 2, 3, and 4. We have to place the lone pairs for the terminal atoms like this. Now 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Then the formal charge here -1. Each and every oxygen atom should induce -1 charge like this. And phosphorus we have placed only 4 electrons. If you could see, that means 1, 2, 3, and 4. But we have to place 5 electrons for phosphorus. So this is inducer +1 charge. So we need to do only one electron transfer from one of the oxygen atom. So at the end of the day, we will have something like this. Phosphorus we have, oxygen, phosphorus, oxygen, 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 and oxygen. There will be a double bond in between these two, each single bond, and here will be 2 lone pairs. Each of others will have 3 lone pairs like this. So these will induce a negative charge. So this is the Lewis dot dash structure for PO4 3 minus ions, right? Like this. If there are any questions, you can ask me. Yeah? I have opened the chat window as well. Yeah. So this is PO4 3 minus ions. If you can remember, when we do the electron transfer, this will induce a +1 charge, this will induce the -1 charge because it's behave as a dative bond. Dative bond එකක් නෙමෙයි, but it shows අපි මතක තියාගන්න පුළුවන්කමට අපි නිකන් කෙටි ක්‍රමයක් විදිහට we think it as a dative bond, right? Right. Then the next one, we'll go to the next one. ClO2 minus ions. දුන්නේ මේක ClO2 minus ions. So we can say the central atom is chlorine. Valence electrons from central atom. Chlorine gives out 7. Then valence electrons from oxygen. That is 6 into 2. electrons from charge, that is +1. Total electrons, that is 7 in 7 plus 12 plus 1. So this is altogether 20. Electron pairs, 10. Then placing the elements like this, ClO2, then the bond pairs like this. Bond pairs are already up. Right. Then other electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. Altogether, let's count. ClO2, 1, 2, 7, 6 into 2, 12, plus 1, that is 20, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So chlorine will get 2, right? Then the formal charges. So in terms of the formal charges, we can say something like this. Let me take the color. We have placed oxygen -1, here also -1. Then chlorine, we have placed these two is for chlorine, these two is also for chlorine, 1 and 1. So we have placed altogether 6 for chlorine, right? So the formal charge will be +1 because chlorine should get 7. So that is +1. So therefore, the transfer should be happening in order to change the in order to reduce the electron density formal charge. We can do only one from here to here. When we do something like that, this will induce +1, this one will induce -1. So at the end of the day, we will have something like this chlorine. There will be a double bond here. In oxygen, there will be 2 lone pairs. Oxygen, there will be 3 lone pairs here. So -1 charge is here. So Lewis dot dash structure will be something like this. So minus charge is here. This is ClO2. And sorry, we have 2 lone pairs on top of chlorine as well. That also need to be mentioned. This is how we draw ClO2 minus ion. If there are any questions, you can ask from me. Yeah? So this is ClO2 minus ions. How to draw ClO2 minus ions? Then let's go to O3. මම මේ පන්තිය දීලා තියෙන සමහර ඒවා ඉම්පෝර්ටන්ට් සමහරට ඔක්කොටම ඉම්පෝර්ටන්ට් ඒවා තමයි. ඔය විභාගෙට ඔය ටර්ම් ටෙස්ට්
So,
වලට හැම ඉඩ තියෙනවා. Yes.
so දැන් ඔය ඩේටිව් බොන්ඩ් එකේ තියෙන එක මේ ඩේටිව් බොන්ඩ් එකේ දැන් ඉලෙක්ට්‍රොන්ස් දෙකක් ක්ලෝරින් වලට දෙනකොට ඒ දෙක ඔක්සිජන් වලින් දුන්නා වගේ නෙමෙයිනේ ඒකෙන් සලකන්නේ. ඒ කියන්නේ ක්ලෝරින් වලින් එකයි ඔක්සිජන් වලින් එකයි කියලා නේ සලකන්නේ.
Yes, yes. ඒක ඇත්තටම වෙන්නේ එහෙම තමයි. මේ ලෙවිස් ස්ට්‍රක්චර් කියන එක ඇත්තටම මේක ප්‍රොසෙස් එකක්. ඒක මිනිස්සු හදාගත්ත ප්‍රොසෙස් එකක්. ඒක ඒ විදිහට නෙමෙයි වෙන්නේ. ඒක ඇත්තටම වෙන්නේ Cl එකයි ඔක්සිජන් එකයි අතර ඩබල් බොන්ඩ් එකක් හදනවා. අර පුතා කිව් විදිහට එතකොට ඔක්සිජන් වලින් එකයි ක්ලෝරින් වලින් එකයි තව එකක් සෙට් වෙලා එක පැත්තක ඩබල් බොන්ඩ් එකක් හදන අනිත් පැත්තෙන් මේ සිංගල් බොන්ඩ් එකක් හදනවා. ඕක මිනිස්සු හදාගත්ත ප්‍රොසෙස් එකක් ලෙවිස් එක. ලෙවිස් ස්ට්‍රක්චර් එක. ඒක නිකන් බොන්ඩ්ස් හැදලා තියෙන කොහොමද කියලා පෙන්눔 කරන්න අපි යූස් කරන එක මෑන් මේඩ් මෙකනිසම් එකක්. ඒක හරි 100% හරි එකක්. කවුරු හරි කෙනෙකුට ප්‍රශ්නයක් තිබුණොත් එහෙම how these bonds are created and how many bonds will be there in between two atoms, something like that. It can be explained by using these Lewis structures. ඒක එතකොට ඩේටිව් බොන්ඩ් එකක් ඇවිල්ලා හැදිලා ඒ කතන්දර නෑ. ඒක වෙනම ස්ටෝරි එකක් පිළිගන්න. එහෙම එකක් වෙන්නේ නෑ මෙතන. ඇත්තටම හැදිලා තියෙන්නේ පුතා අපේ හොඳයි. මේක ඇත්තටම හැදිලා තියෙන මේක ක්ලෝරින් ඔක්සිජන් අතර ඩබල් බොන්ඩ් එකක් සහ ක්ලෝරින් oxygen අනිත් පැත්තෙන් single bond එකක් and it is having a minus charge. I will be explaining why it is having a minus charge in our day after tomorrow class. Oxo acid එකකින් තමයි මේ වැඩේ වෙලා තියෙන්නේ. Right. We will be drawing about the oxo acids in our next class. මෙතන හයිඩ්‍රජන් එකක් තිබලා හයිඩ්‍රජන් එක ගිහිල්ලා ඒකයි නෙගටිව් charge එකක් ඇවිල්ලා තියෙන්නේ. Right. So with oxygen. ප්‍රශ්න අපි හොඳයි. හොඳ ප්‍රශ්නයක්. Right. Then let's go to the next one. Then O3. O3 is ozone. අපි මතක් කරනවා. This is ozone. Here there is no argument. Oxygen should be the central atom, and there will be two oxygen atoms as the leaf atoms or terminal atoms. Right. So central atom. මේවා ඕනේ නෑ මේ පුරුදු වෙනකම් මම ලියන්නේ valence electrons, but for the term test you have to write this down. Valence electrons from central atom 6, then valence electrons from oxygen, that is also 6 into 2. There are no charges, so altogether total electrons there will be 18, not 16. Then electron pairs 9. දැන් මේක පොඩ්ඩක් විතර වගේ පොඩි ට්‍රික් එකක් තියෙනවා බලන්න. Oxygen will be here and other two oxygen will also be here. So now it's time to place the bond pairs, right? 1, 2. Then it's time to place the terminal atom oxygen, sorry, terminal atom lone pairs. We have placed 2, 3, 4, 5, 6, 7, 8, and 9. Right? දැන් මොකක්ද ස්ටෝරි එක තියෙන්නේ. හරිද? Then the formal charges. When it comes to formal charges, here it is -1, here also -1. To the central oxygen atom, we have placed only 1, 3, and 4. So this should induce +2 charge. Right? +2 charge. Then let's try to minimize the formal charges. In order to minimize the formal charges, we can do something like this. Then මේක අපි නිකන් මම බොන්ඩ් එකක් ඇඳලා මං කරන්න. හරි මේක හොඳට පේනවා ඒක right. ඔන්න ඔහොම ඉන්නේ. ඩෑෂ් එක ගහපුවම ඔහොම සීන් එකක් එන්නේ. හරිද? So this is -1. This is +2. Like this, there will be one lone pair in between these two. Then we know oxygen can create only two two bonds. Two bonds has been created now, but we have a problem with the formal charges, and also the electron octet is not fulfilled around the central oxygen atom. So we learned that formal charge becomes formal charge will be deprioritized when it comes to the fulfilling the electron octet. We have to fulfill the electron octet. So therefore we will do one day tube on something like that, like our process, right? So I will do a donation like this. So this will induce plus one charge, this will induce minus one charge. Then at the end of the day we will have something like this. දැන් මම මේක මකන්න ඉස්සෙල්ලා අර ඒකට මේ කතන්දරේ මෙන්න මේ වගේ එකකට කන්වර්ට් වෙනවා. හරිද? Oxygen lone pair here. Here also oxygen. There will be a double bond in between these two. Like this. Bond pair. Then we have formal charges. Here we have plus one on top of the central atom. Here we have minus one. If you check the electron octet, central atom is also fulfilled the electron octet. All others are also fulfilled the electron octet. So if I draw the Lewis dot dash structure, it's something like this: oxygen, single bond here, double bond here, and we have two lone pairs here, one lone pair here. Here we have three lone pairs, and we have plus one here and minus one here. This is the structure for ozone. We have overcome the octet rule compared to the formal charge thing. Formal charge has been deprioritized to fulfill the electron octet. එතකොට දැන් ඇත්තටම මේක කොහොමද වෙලා තියෙන්නේ කියලා අපි හිතමු. මම අර කියලා දුන්න මේක ඇනලයිස් කරන්න කියලා. මේක ඇත්තටම වෙලා තියෙන්නේ කොහොමද දන්නවද? මේ ඕසෝන් එක හැදෙන්නේ කොහොමද දන්නවද? Ozone will be created. So this is the structure for ozone. There is no argument on this one. This is the structure for ozone. We can confirm it by using the Lewis structures as well. දැන් අපි මේක කෙමිස්ට්‍රි වලදී මේක හැදෙන හැටි ඉගෙන ගත්තොත් එහෙම කෙමිස්ට්‍රි හැටියට මේක හැදෙන්නේ කොහොමද දන්නවද? මෙන්න මෙහෙම හැදෙන්නේ. මේ අපි ඉගෙන ගන්නවා ඉස්සරහට. Oxygen double bond is there. So this is oxygen molecule, right? Now if we have something like this, oxygen complete molecule, not molecule, oxygen atom, something like this comes near free oxygen atom comes near. What will happen is there will be a dative bond from this lone pair to here. Because of this dative bond, this will induce a plus one charge. This one induce a negative one charge. This is how ozone is created. The bond is the dative bond, and it is indicated in our Lewis diagram as well. Formal charging අන්තිම විතරලා තියෙනවා plus one and minus one here. So that is the dative bond. So obviously, what has happened is oxygen molecule is there. From oxygen molecule, one lone pair has been donated to one oxygen atom. Then this is how ozone molecule is created, right? So this is in terms of chemistry what has happened. This one, we have oxygen molecule and the dative bond towards one oxygen atom, right?
සර් ඒ -1 charge එක නැති කරන්න පුළුවන් නේ තව ඩේටි බොන්ඩ් එකක් හදාගෙන. ඇයි ඔහොම තියෙන්නේ ඔය ස්ටේට් එකේ?
මේ ස්ටේට් එකේ තියෙන්නේ because at this state oxygen has fulfilled the electron octet. එයාට ඊට වැඩි යන්න බෑ. right? දැන් හිතන්න මේක මෙහෙම දැම්මයි කියලා. අපි එතන නතර වෙන්න වෙනවා අනිවාර්යයෙන්. මේක මේ පැත්තට කැඩුවයි කියලා හිතන්න. එතකොට මේ මොනසට මෙහෙම එකක් වෙටෙනවනේ. එතකොට oxygen is having how many electrons? 1 2 3 4 5 6 here. 1 2 3 4 5 6 7 8 9 10. Oxygen can't get 10 because oxygen is in the second period. එකත් හිතන්න ඕන. එතකොට ඒක අනිත් පැත්තට කඩන්න බෑ. We can't eliminate that charge. Oxygen is in the second period, it can only take 8 electrons. Now let's say this is sulfur or something like that. එතකොට හදනවා. තේරෙනවද අනිත් පැත්තට කඩන්න බැරි කියලා? Because that is coming from the electron octet. තේරුණා?
තේරුණා සර්.
හරි. Okay. Now the ozone structure is like this. What term test වලට විභාගෙට ozone එහෙම අහලා තියෙනවා සෑහෙන සැරයක්. Right. So theories would be අපි මේක මෙතනින් නතර කරන්නේ නැත්තේ why we don't stop from here. I'm talking about here, this one. ඔතන dative bond එක දාලා dative bond එක දාන්න නැතුව එතනින් නතර කරන්නේ නැත්තේ because we need to eliminate the formal charges and as well as I need to complete the electron octet as well, right? So that is the reason. Okay. Now let's go to the next one. Ozone is special one, right? Then we have given NO2F. මම මේ කරගෙන යන අර මේක දුන්න ටික හොඳ. මේ ක්ලාස් එකේ දුන්න ටික. මට මේ ඔක්කොම ටික ක්ලාස් එකේ කරන් වෙලාවක් නැති වෙයි. Right? So NO2F. So definitely central atom should be nitrogen. NO2F වල central atom should be nitrogen. So central atom is nitrogen. Then valence electrons 5. Valence electrons from oxygen, that is 6 into 2. Valence electrons from fluorine, that is 7. Fluorine is in the 17th group, right? Then total electrons 5 plus 7 plus 12, that is 24. Then E pairs 12. Now yeah. Then now we have to place the central atom. Yeah, nitrogen, oxygen, oxygen, and fluorine. Then the electron pair story. Here, bond pairs. Now 3, starting from the most electronegative one. We have to start from them fluorine, right? 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Then the formal charges, right? So when it comes to the formal charges, here it is -1, -1. Fluorine is not -1. Fluorine, we have placed 7, so add a -1 එකක් නැහැ, right? Because fluorine we have placed 7 electrons, right? We have placed 7 electrons. If you count the number of atoms we have allocated for fluorine, that is 7. මෙතන තියෙන එකක්, මෙන්න මෙතන තියෙන එකක්, one belongs to nitrogen. So altogether we have placed 7 electrons for fluorine. So there is no formal charge for fluorine, right? Then here we have -1 charge. In terms of nitrogen, we have placed uh, 3 electrons. It need to have it need to have 2 electrons here, right? So 2 electrons more. So therefore, it will induce +2 charge here. Then let's talk about let's try to complete the electron octet while reducing the formal charge. Now nitrogen already have 6 electrons around. So therefore, we need to have only one electron pair sharing. Only one electron pair sharing in between nitrogen and oxygen, right? So we need to create something like this then, like this, because nitrogen cannot, we can't do more uh, electron pair sharing because nitrogen can create only 8 around the nitrogen atom. So because of this one, this will induce +1, this will induce -1. Now at the end of the day, we will have something like this: nitrogen, oxygen, oxygen, and fluorine. Then let's place the electrons here: 1, 2, 3, 4, then 5 and 6. There's a double bond and a single bond here, like this. So this will induce +1 charge. This will induce -1 charge. So if I draw the Lewis dot dash structure: nitrogen, double bond O, single bond fluorine, O, here it is +1, here it is -1. So we have to place the lone pairs like this. So this is the structure for NO2F. Make here nitrogen has created a double bond and a single bond. Okay. And after creating this one, nitrogen has consumed 3 electrons to 3 bonds, and there will be a lone pair. When oxygen atom comes closer as previous, like this, and a dative bond is created in between these two, this will induce +1 and this will induce a -1. මේ වෙච්ච දේ අපේ ලෙවිස් diagram එකෙන් exactly එනවා, right? So this is a dative bond. අපි ඉගෙනගෙන තියෙනවා dative bond at the end of the day it's a covalent bond, right? So this is the Lewis dot dash structure. Lewis dot dash Lewis structures is a very powerful mechanism to draw the molecules. Right? අපි ලබන සතිය කරන molecule shapes අනම්මනම් කරනකොට නම් ඔයාලට තේරෙයි කතන්දරේ කොහොමද මේ Lewis dot dash එක මෙච්චර how powerful is it, right? So this is how we draw NO2F. Why we then කලින් ප්‍රශ්නෙට මම උත්තර දෙනවා, why we are not eliminating the other formal charge, that means -1 and +1, by creating a double bond in between oxygen and nitrogen, because nitrogen cannot create more than 8 electrons around itself, because nitrogen is coming from second period. එයාට ගන්න පුළුවන් maximum 8, right? ඔන්න ඊළඟට එනවා මේක කාටද කෙනෙකුට ඇඳ ගන්න ඕන. අග්ගල ඇඳ ගන්න ඕන. Let's go to the next one. Do it at home. මට මේ ටික කියලා දෙන්න තමයි ඕන කරන්නේ ස්පෙෂල් ටික. S2O3 2 minus ions. මේකට අපි කියනවා thiosulfate ion. Thiosulfate ion. Thiosulfate ion. So the central atom obviously should be one of the sulfur atom, right? So central atom sulfur, electrons from sulfur central 6, electrons from sulfur terminal. There should be terminal 1 as well because S2, right? Again 6, electrons from oxygen atoms 6 into 3, electrons from charge plus 2, that is minus 2, so it should be plus. Total electrons 6 plus 6 plus 18 plus 2, 12 30 32, right? Then E pairs 16. Then sulfur, this is the central sulfur, then I'm placing the terminal sulfur, oxygen, oxygen, and oxygen. Then placing bond pairs. 1, 2, 3, and 4. Then lone pairs for terminal atoms. 16 තියෙනවානේ. 12 අපි දන්නවා 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. හතරක් අපි already use කරලා තියෙනවා, so all to be 16. Then the formal charge, right? Next step is the formal charge. Each and every oxygen atom should induce -1 charge. Here, this sulfur is also induce a -1 charge because we have placed 7 electrons around sulfur. Sulfur should have only 6. So this is having a -1 charge. Then the central sulfur atom, we have placed 4. We have placed 4, right? Then it will induce +2 charge because we have placed only 4 electrons. Then you have to keep that in mind. Sulfur is from the third period, right? It can accommodate more than electron octet. So we can minimize the formal charge as much as possible because it can accommodate more than octet, right? එතකොට මම මේ +2 එකම අයින් කරලා දානවා. How I can remove the +2 is doing something like this. I can do a dative bond kind of structure from here and from here as well. Then oxygen වගේ එකක් තිබුණා නම් මේ වැඩේ වෙන්නේ නැහැ. Let's say that the sulfur is from the second period. We can't do this one. That sulfur is from the third period. So it can accommodate more than the electron octet. Then we can see a structure like this sulfur. Let's say sulfur here, terminal sulfur, sulfur, oxygen, oxygen, and oxygen. We have a double bond here like this, and we have a double bond here like this, and a single bond, and a single bond. We have lone pair, 2 lone pairs, and we have 3 lone pairs here, and we have 3 lone pairs here, three lone pairs here. So these have induced -1. This is also -1. Here we can see two lone pairs. So this is the Lewis dot structure for S2O3 2 minus ions. If I draw the Lewis dot dash structure, it's something like this: sulfur, sulfur, double bond sulfur, single bond oxygen, minus charge, double bond oxygen, like this, minus charge. So we will have to place the lone pairs as well, like this, three lone pairs on each of O minus and two lone pairs on the sulfur, like this, and two lone pairs on this oxygen. So this is the structure for S2O3 2 minus. S2O3 2 minus and thiosulfate ion. So if you check the total number of electrons around the central sulfur atom, that is 1, 2, 3, 4, 5, 6, that is 12. So it has more than electron octet, right? It has electron efficiency because that is coming from the third period. If I, as I explained previously as well, assume sulfur is coming from the second period, then it will stop from the electron octet, right? If it can go more beyond the electron octet, then we should consider the minimizing the formal charges as much as possible, right? Right. The next one, NO3 minus ions, right? So the central atom should be nitrogen. Then electron from oxygen, sorry, electrons from, let's say electrons from nitrogen. No, I think Purana Prasna. Then electrons from three oxygen atoms, 6 into 3. Electron from charge, +1. Total electrons, 18 plus 6, 18 plus 5 plus 1, that is 6. So altogether 24 electron pairs, 12, right? Then placing the atoms, nitrogen, oxygen, oxygen, oxygen. Then the bond pairs, 1, 2, and 3. Placing others, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Nice. Then the formal charges. When it comes to formal charges, here it is -1, here it is -1, here it is -1. Nitrogen, it should be +1, right? 1, 2, 3, no, +2. Because it has placed only 3 electrons, it should have 5 electrons. So we formal charge should be +2. Remember, we have placed already 6 electrons around nitrogen. It can only accommodate 2 more for nitrogen. So only one dative bond will be there. Dative bond like something like that. So electron pair sharing. So I will do like this. So at the end of the day, we can see something like this: nitrogen, oxygen, oxygen, and oxygen. We have a double bond in between these two, single bond here. Nitrogen will induce plus one charge. Yeah, plus one charge because we can't eliminate this one. Here it is minus one. Here it is minus one. I couldn't place something like this. These two as well. So the Lewis dot dash structure will be something like this: nitrogen double bond O oxygen. There will be a minus charge. Oxygen, something like this. So this will induce minus one and plus one. මේක ඇත්තටම වෙලා තියෙන්නේ මෙන්න මේ වගේ දෙයක්. This is NO3 minus ion. This is a dative bond. You can see that one, right? And the other one, this one, it was there OH bond. ඕට තව එකක් සෙට් වෙලා තිබිලා තියෙනවා මෙතන. මේක අපි ඉගෙන ගන්නවා, right? මෙතන H එකක් තිබිලා තියෙනවා. Here. Oxygen එක. It has been released by taking both the electrons towards the oxygen atom. That's why it has induced a negative charge. That is not because of a dative bond. හරිද? මේක තිබිලා තියෙන්නේ මෙන්න මේ වගේ ස්ට්‍රක්චර් එකක්. නිකන් මේ කුතුහලයේ තියෙන හින්දා මම කියන්නේ මේ කොහොමද දෙන්නේ කියන එක. හරිද? Nitrogen OH double bond O. This is the dative bond. This was there, right? Then what has happened is this bond has been disassociated by taking both electrons towards the oxygen atom. එයා share කරලා තිබුණ එකයි hydrogen share කරලා තිබුණ එකයි both has been taken from oxygen. So it will induce an excess of one electron. Therefore, minus one charge will be there. Hydrogen plus විදිහට යනවා. H plus. Right. ඒක තමයි මෙතන තියෙන්නේ. අපේ Lewis structure එකෙන් ඕක නියමටම එනවා. Right. So this is a dative bond then. That's why plus one and minus one is there. The other oxygen atom minus charge is because of the bond cleavage or bond disassociation. Right? So you can see the Lewis dot dash structure for NO3 minus ions. Okay. Then let's go to the next one. Go on the random. I3 minus, IO3 minus, IF3 and CLF3. I will leave it to you, Buddha. මේවා ඔයාලා දැන් පුළුවන් වෙන්න ඕන. I3 minus, IO3 minus මේ වගේ ස්පෙෂල් දෙයක් නෑ මොකුත්. IF3 and CLF3. මේවා ගෙදරදී කරන්න. හරිද? Then I will go to HCN. I will leave these four for you. Then I will go to HCN. So obviously carbon should be the central atom for this one, right? So central atom, carbon. Then valence electrons from carbon, that is 4, nitrogen 5, hydrogen 1. There is no charge. Then total, that is 8, E pairs 5, right? Then let's place carbon is central, hydrogen and nitrogen, one bond pair දාන්න මේක ටිකක් ලොකු කරන්න ඕනේ. එතකොට තමයි හරියන්නේ. Like this. 1, 2, 3, 4 and 5. මම හිතනවා මේක ඇඳා. ගෙදර මේ ක්ලාස් එකේ කමන්නේ. පාට වැඩියෙන් තිබ්බද මම? Yes. So carbon has 4, nitrogen has 5, and hydrogen has 1. Then total there is 10, electron pairs 5. So let's place the formal charges then. Here the formal charge on top of carbon atom 1, 2, 3, 4. There is no formal charge here. Then on top of nitrogen atom, that is +1 is here. Sorry, no formal charge, no? On top of nitrogen atom is also there is no formal charge. So we can place the 5 electrons without any formal charges. Hydrogen we have placed 1 electron, carbon we have placed 2, 3 and 4. Nitrogen also we have placed 2, 3 and 4. So the structure is very clear. This is something that we can expect. Nitrogen like this. No formal charges. But we have a problem here. The problem is electron octet is not fulfilled. Right? Electron octet is not fulfilled here. How to, because carbon 1, 2, 3, 4, 5, 6, right? Carbon is 6. Nitrogen 1, 2, 3, 4, 5, 6. Nitrogen is also 6. So what we could do is we will place a lone pair in between these two, like this, right? Then we can see something like this. Hydrogen, carbon, then a double bond, nitrogen, and like this, right? So now let's count the total number of electrons. Hydrogen, there is no count. Carbon, 1, 2, 3, 4, 5, 6, 7, 8. Octet has been fulfilled. How about nitrogen? Nitrogen, 1, 2, 3, 4, 5, 6. Nitrogen still has 6, right? But we have to fulfill the electron octet for nitrogen as well. Then we have to transfer these two electrons in between these. Nitrogen එක දුන්නයි කියලා වැඩක් වෙන්නේ නැහැ. We have to transfer the electron pair in between carbon as well. The nitrogen එක දුන්නට පස්සේ there is no increment of electrons in between. Sorry, there is no increment in the number of electrons around the nitrogen. So we have to transfer that carbon lone pair in between carbon and nitrogen. Then at the end of the day, we will have hydrogen, carbon, and a triple bond, nitrogen, and the lone pair is here. Lone pair, no lone pair for carbon. Now let's count the electron octet. Carbon is having then 8, triple bond එක 6ක් ගන්නවා. Nitrogen is also having 8. This is the correct structure for HCl. මේකෙදෙන විශේෂත්වය තමයි we are not dealing with the formal charges here. We are dealing with to complete the electron octet, right? So at the end of the day, what we can have is hydrogen, carbon, a triple bond, and a lone pair here. This is HCl. Hydrogen, it is not taking the electron octet. Carbon has fulfilled its electron octet. Nitrogen is also fulfilled its electron octet. So this is quite interesting one in Lewis structures. There are no formal charges. We are dealing with to fulfill the electron octet. So this is a special one. This is HCl, final one.
නයිට්‍රජන් එක බොන්ඩන සාමාන්‍යයෙන් ගොඩක් බොන්ඩිංස් මේ most of the time again triple bond එකක්ද වෙන්නේ නැත්නම් most of the time මම
Most of the time triple bond. Correct. ඒක හරියටම percentage එකක් විදිහට කියන්න බෑ. මම අර note එකට මම දුන්නා මම මතක හැටියට. nitrogen ගන්න ආකාර ගොඩක් තියෙනවා. So nitrogen එයා තනි එකක් එක්ක එනවා නම් if the other one is also can create a triple bond, then carbon can create a triple bond, right? Because carbon has 4 valence electrons. So it can facilitate the triple bond. ඒක triple bond එක facilitate කරන්න පුළුවන් නම් it will create the triple bond straight away. හැබැයි ප්‍රශ්නයකට තියෙන්නේ nitrogen can show single bond, 3 single bonds as well very occasionally, right? Very frequently. For an example, ammonia, right? NF3. කොහොම හරි යාට තුනක් තමයි ඕන කරන්නේ. Most of the time triple bond එකක් ගහනවා. හැබැයි අනිත් කෙනාට triple bond එකක් හදන්න පුළුවන් වෙන්න ඕන. There should be there. For an example, N2, both of them can create triple bonds. ඒක අපිට හරියන hard and fast rule එකක් විදිහට තියාගන්න එපා. තැනේ හැටියට තමයි වැඩේ කරන්න ඕනේ. Okay, then I will go to N2O3. නිදිමතද නෑනේ. මේ ටික අපි ඉවර කරමුනේ. අන්තිම තව තුනක් තියෙනවා. N2O3. N2O3. So the central atom should be nitrogen. Right. So electron from central nitrogen 5. Then terminal nitrogen, that is also 5. Oxygen 3 into 6 into 3, that is 18. Total 28 E pairs. 14. So let's place N2O3. දැන් මේකේ තියෙනකොට අපි පොඩ්ඩක් මේක ස්මාර්ට් වෙන්න ඕනේ මේ කතන්දරේදී. හරිද? N2O3 කතන්දරේදී we have to be smart on this one. On placing the atoms. Because this is a non-symmetrical molecule, not a symmetrical molecule. Which means there can be two central atoms, virtual, right? So how I place this as like this: nitrogen, oxygen, nitrogen, oxygen, and nitrogen. එක එක විදිහට ප්ලේස් කරන්න පුළුවන් මේක. පුතාලට කැමති නම් මේක මෙහෙම තියන්නත් පුළුවන්. nitrogen, oxygen, oxygen, nitrogen, and oxygen. This is also a method. This is also N2O3, no? එහෙමත් නැත්නම් මේක මෙහෙම තියන්නත් පුළුවන්. nitrogen, nitrogen, oxygen, oxygen, and oxygen. Wait, let me draw it here. Oxygen, nitrogen, nitrogen, oxygen, and oxygen. Then make a. I think there are no any other atom placements, right? Because this is this problem arises in non-symmetrical elements. Now, ඔයාලා දන්නේ නැති පාර්ට් එකක් මෙතන තියෙනවා මට කියලා දෙන්න. Let's think about the first arrangement. කට්ටියට නිදිමත නැතිව ඇති කියලා හිතලාද මම දැන් කියලා දෙන්න ගන්නේ. හොඳට අහගෙන ඉන්න ඕනේ. Let's consider this one. In here, if you consider these two, nitrogen and oxygen, and these two, this nitrogen and oxygen, nitrogen can accommodate only two bonds, right? So the terminal nitrogen atom connected to oxygen, I'm talking about this one, can only take one bond because there is no any other element for nitrogen. So therefore that nitrogen cannot create the electron octet. So that is unstable. Same scenario is here as well. In this scenario, මොකක් හරි ගිල් මාට්ටයක් දාගන්න පුළුවන් because nitrogen can create triple bond and oxygen can create a double bond. මොකක් හරි සෙල්ලමක් දාලා වැඩේ balance කරගන්න පුළුවන්. Right? So when you are, if there are many atom placements, you have to be smart to place the atoms in the correct position. Usually we are not placing elements like nitrogen as terminals because nitrogen need to take three bonds, right? So placing it as a terminal element, it will lost completely one side. So එතකොට එයාකට එක පැත්තකින් විතරයි එතකොට set වෙන්න වෙන්නේ. අනිත් පැත්තේ නැහැ. Like in first and second element placement. But in the second placement, sorry, third placement, තුන්වෙනිට අපි දාලා තියෙන එකේ. So that is, we can manage something because nitrogen can create a triple bond and oxygen is also can create a double bond. ඕන් දැන් අපි තුන්වෙනි එක තමයි ඊට පස්සේ ගන්න. මේක මට තව දෙයක් කියලා දෙන්න තියෙනවා. හරිද? The other one is, think about this one පුතේ. Here, this one. In between these two, you cannot create oxygen oxygen double bond because oxygen need to create අපි දුම මෙහෙම එකක් තියෙනවා කියලා කොහෙද දැනගන්න. Then oxygen oxygen double bond is not possible here. Only a single bond is possible. Right? Only a single bond is possible here. So oxygen oxygen single bond is unstable in chemistry. අපි මම ඉගෙන ගන්නවා ඉස්සරහට. දැනට මතක තියාගන්න මේ වගේ ඉලෙක්ට්‍රෝන ප්ලේස්මන්ට් එකක් අපි කරන්නේ නැහැ ගොඩක් වෙලාවට. Oxygen oxygen single bond is unstable. ඒක ගොඩක් වෙලාවට කැඩෙන්න බලනවා. Right? So in the oxygen oxygen placement, I will repeat again. I think sort of detach උනානේ. Drop උනා. I explain කරන්න. If you take the second one, right, second element placement, the second element placement, there is something that you need to know. What you need to know here is, in the second one, there is oxygen oxygen scenario here. I'm talking about this one. Only possible way placing a bond pair is only a single bond in between these two because there are two other elements surrounding them. So oxygen oxygen single bond in chemistry is unstable. So therefore we are not placing something like that if and only if there is no other choice. choice නැත්තම් place කරාට කමක් නැහැ. But we have a place like this, right? So third one could be taken as the correct element placement. Now let's consider the third electron placement, sorry, element placement. So here oxygen, nitrogen, nitrogen, oxygen, and oxygen. So we have 14 bond pairs, right? Not the bond pairs, electron pairs. We will place bond pairs first. So we have consumed 5 here. 1, 2, 3, 4, 4. Sorry, 4. Then placing electrons starting from the terminal. 1, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then we have left with one more lone pair, one more electron pair. අපි කෝකටද දාන්නේ මේක? First one, first nitrogen or second nitrogen? Second nitrogen we have already placed 6, right? Or 3 bond pairs. First nitrogen we have only 2. So we have to place the remaining one to the first nitrogen because we have placed only 2 there, right? So I will place it here. Now we have placed 14, right? 8, 9, 10, 11, 12, 13, 14, 15. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now altogether 14 is there. Now the charges, formal charges, right? So the formal charges is, here it is -1, here it is -1, here it is -1. Nitrogen, each of them have +2, right? Now, keeping in mind, nitrogen can create only 8 electrons. Let's try to minimize the formal charges, right? Now, what I can do is, I will take 2 lone pairs from oxygen here. Then 8 electrons is completed for the second nitrogen atom. I will do the same for here as well, right? So because of that, this one induce a +1, this one induce a -1, this one induce +1, this one induce -1, right? At the end of the day, we will have something like this: oxygen, nitrogen, nitrogen, oxygen, oxygen. There will be a double bond here. There will be a double bond here. Single bond, single bond. And we will have lone pair here and a +1 charge. We have +1 charge here and a lone pair and a lone pair, lone pair, lone pair, lone pair, lone pair, -1. Now, did I do a mistake here? This is +2, -1. This is -1, +1. Here this is 0. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3. Now, take a look on this one. We have +1 here and +1 here as well after creating this one. This is something new that we need to learn. If there are two consecutive elements with plus charges, that means if plus charges has induced in two consecutive elements, that is also unstable, right? That is also unstable. That is something we will learn in the next lesson. Having plus two charges in consecutive elements is unstable. So therefore, this structure is regarded as an unstable structure. So what we shall do is something like this. So we have nitrogen, nitrogen, oxygen and oxygen, oxygen and lone pair here. When we are transferring the electrons, we need to consider that part as well. So it is having minus 1, here it is plus 2, here it is plus 2, here it is minus 1, right? Now, this one we have no problem with the electron transition from this one, we have no problem. What I shall do is, I will do the electron transition from here to here. From oxygen to nitrogen I can do, but I will do from nitrogen to nitrogen. That is also possible, right? Can do. Then we are left with something like this. See, nitrogen, nitrogen, oxygen and oxygen. There will be a double bond in between these two, and a single bond, and a single bond. There will be here, because of the dative bonds that we have constructed, this is plus 1, this is minus 1. Because of this one, this is plus 1, and this is minus 1, right? Then we can see something like this. Oxygen, single bond, like this, and this will induce a plus 1 charge. This one has induced a negative 1 charge, and this one 0 charge. This one has induced a minus 1 charge, and this one has no charge here. Let me draw like this. Oxygen, minus 1 charge. So there will be no charge on top of this one, and the other ones as well. So we could see something like this. This has induced a plus 1 charge, and other one has induced a negative 1 charge, and the total accepted structure is something like this. This is N2O3, right? There's a question. One nitrogen is plus 1. Did I do a mistake here? I think this is plus 1, right? Nitrogen 1. Minus 1, minus 1. 1, 2, 3, plus 2, Yes, here minus 1, and this is also plus 1. Yeah, so this should be plus 1 charge, right? Like this. Since the charge of one nitrogen is plus 1, so this is plus 1. Yes, correct. So this one is accepted as the N2O3 structure, right? So what you need to learn here is මේක තේරෙන්නේ නැතුනොත් ප්‍රශ්නයක් නෑ. මම මේ theory class එකේදී මම කියලා දෙනවා. This one is wrong because consecutive elements, two plus ions, is unstable, right? This is the structure for N2O3. මේක ඇත්තටම වෙන්නේ මෙන්න මේ වගේ කතන්දරයක්. හරිද? අපි වෙන දේ බලාගමු මේකේ. Here double bond has missed, no? Yeah, this one. We need to create a double bond here, no? Double bond will be there. Wait. Yeah. Yes. There is an issue. There is an error here. I also missed that part. This cannot be happen. This one. This one cannot be happen. So therefore, why it is cannot happen is the electron octet, right? So at the end of the day, we have something like this: nitrogen, oxygen, one bond here, minus one charge. Then we have one bond here, minus one charge. This is plus one. There will be a double bond in between these two. Then we have something like this, minus one, like this. So this is also has induced a plus one charge on top of this one. So this plus one and minus one, this is double bond oxygen. This is plus two. This is a plus two one, because not plus one, this is plus two. So this can be accepted as N2O3, this one, right? මේක තේරුම් නැත්නම් මම විභාගෙදී මේ sorry මේ ක්ලාස් එකේදී මම කියලා දෙන්නම්. ප්ලස් දෙකක් තියෙන එක මේක ඇත්තටම N2O3 කියන එක හරිම අන්ස්ටේබල් එකක්. අපිට ගන්න බෑ මට තේරෙන විදිහට ප්ලස් දෙකක් නැති. ප්ලස් දෙකක් එක ළඟ නැති දෙකක් විදිහට ගන්න බෑ. There was another question in the part. I mean the first step is in the charge of the one is plus and another one is plus two. The question is, in the first step, isn't the charge of one n is plus one and other is plus two? No, right? N2O3. I have placed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, that is plus 2. 1, 2, 3, that is also plus 2. So it's formal charges. I think that is correct. Why you think that 1 is having plus 1 on top of nitrogen? Yes. Yes. Nalani. Wait. I have done the mistake. Correct. Wait. Let me correct this one. into O3. So the structure is something like this. Let me go from the beginning, right? Nitrogen, then here nitrogen, oxygen, nitrogen, oxygen, and nitrogen. So we will place the bond pairs 1, 2, 3, and 4, right? And we are placing 14 electron pairs. Right? I have done the mistake. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, how much? Sorry, 13 and 14 we are placing here. This is the mistake that I have done. That's why I'm also thinking it cannot be. So here, oxygen -1, there is no issue, right? Now here, this nitrogen we have placed 1, 2, and 3, right? So that is +2. For this nitrogen, 2, 3, and 4, here this is +1. That is the issue that I have made, right? So the formal charge of nitrogen here it is +1 because I have taken that lone pair as a uh, 1 electron. That is the issue. Now, having said that, now there is no problem. I was also thinking it can't be, that's why. So thank you for pointing it out. Now we will have something like this at the end. The lone pairs and like this. Then the electron transition. The electron transition, and let's you may take a wonderful one. We will have something, no, I need to eliminate this positive charges, right? So I will do this transition, right? And I want to do this transition. Then uh, 3. අපි මේක අනිත් පැත්තට දාමු බලන්න. අනිත් පැත්තට දැම්මම මේ වැඩේ උඩ යනවා. අපිට අනිත් පැත්තට දාමු. ඒත් positive charge එක නැති වෙලා යනවා. So something like this we will do. Then we will have oxygen, nitrogen, nitrogen, oxygen, and oxygen. We have double bond here. මේක මේ පැත්තට අනිත් පැත්තට දෙන්න ඕන. The other way around. From here to here. Otherwise, plus charge will be increased. Then because of that one, we will have something like this. Here this will induce a +1 charge. This one induce a -1 charge. Then we will have one bond here, one bond here, and one bond here. This one induce a +2 charge. Something like this. Then this is -1 and this is -1. Then electron octet is not fulfilled around this nitrogen atom, right? Where is it? This one. Around this nitrogen atom, electron octet is not fulfilled. So therefore, what I shall do is, I will take one lone pair from here to here. Oxygen, double bond here, nitrogen, single bond, nitrogen, and a double bond in between these two, oxygen, and a single bond in between these two. This has induced a +1 charge. This one has induced a -1 charge. And there will be two lone pairs like this. and one lone pair on top of this nitrogen atom as well. So Lewis dot dash structure we can draw oxygen double bond O N single bond O and a double bond O here. This is oxygen, not N. Oxygen. Then we have -1 charge, +1 charge. This is because of the dative bond. Oh yeah, I it. It's like this. So this is N2O3, right? So what I have done is I have placed the atoms oxygen, nitrogen, nitrogen, and oxygen. What I have done the mistake here is this one, placing the formal charge. That should be +1, right? Then I have done an electron transition from oxygen to nitrogen because in order to reduce the lone pair, in order to reduce the formal charge. So that is this one. Then I can minimize it further to fulfill the electron octet of this nitrogen atom. I have done that part as well. So at the end of the day, I ended up with something like this, and I will come to this part. So this is the correct structure for N2O3. So මගේ අතින් පොඩි complex mistake එකක් වුණා ඒක. We can correct in this way. In this way. Right. ඉතිරි දෙක මම yeah, I will do it at the class. I need to you try this one. N2O5 මේ method එකම තමයි යන්න තියෙන්නේ. N2O5 and N2O4. Try these two at home and come to the class. I will do this one at the class. Yeah, I will do this one at the class. Were there any question? No, right? No. Okay. So I will do these two at class. So we will stop the class from here for today. May N2O3 Kaipara Kandinda. There was one small mistake from me. That is from the formal charge. ඒක නැති වුනහම වෙන කතන්දරේ දැක්කනේ, right? Okay. So we will stop the class from here for today. We will have the class at 12:30 this time. 30 minutes paper එකක් දෙන්නේ. Come at 12:30. කලින් එන්න පුළුවන් ප්‍රශ්න නැහැ. So 30-minute paper and I will start the class at 1. We will be doing chemical bonds, Lewis structure, and I'll be starting the molecular shapes, right? And chemical calculations, I'll be continuing to do concentration and I'll be explaining the concept of mole fraction as well, right? Okay then, අපි class එක නවත්තමු. Thank you very much. Good night.